Hello, my name is Felix Marks, and welcome to the QRadar kill chain demo. Let's set the scene with a couple of slides. In the first slide, we can see the anatomy of the kill chain as perpetrated by an external attacker or threat actor. First, the attacker breaches the company's defenses and gains a foothold, perhaps using a drive-by download, phishing, or social engineering attack. Next, now that the attacker has a foothold, reconnaissance is conducted and the lateral attack progresses towards high-value targets containing data that's worth stealing and possibly destroying. Whether it's an individual or a gang of professional black hats, or even a state actor, the tools and methods are much the same. So here's some background to what you're going to see. This is real hacking with real hacking tools, and we're going to be hacking into an up-to-date Windows 7 machine. We're going to break in, we're going to find some files to steal, and then we're going to try to clear up after ourselves. And at the same time, we'll see what QRadar would have seen. The first part of the attack has already happened, so we're already in the target network, and we're looking for high-value targets to exfiltrate from. We'll assume that a user has been duped into going to a website, having been phoned by somebody posing as the company's IT department. An alternative scenario is where we start from the premise that we're just a disgruntled employee looking to steal valuable information, and that's why we're in the company's network. Either way, it's lateral movement. As a result of the first part of the attack being successful, we have a foothold as a normal user in that network. This is what we're going to see in the demo. We start with a foothold and see that this event is automatically identified by QRadar using IBM's X-Force service. Next, we're going to see how QRadar detects the Nmap port scanning of the victim's machine and then detects the pass-the-hash PowerShell exploit. Then finally, that QRadar picks up the log file clearance as the attacker attempts to cover his or her tracks. We're going to view the demo from 3 different perspectives simultaneously. On the bottom left is the attacker's view. On the bottom right is the victim, a machine called Finance, which is running an up-to-date version of Windows 7. Across the top of the screen, we have QRadar. Let's look around the QRadar GUI. The way QRadar works is by turning huge numbers of log events that appear in the log activity window, which is here, large amounts of network flows, which we're going to see appear here in network activity, and finally, a small number of actionable security events that will appear here in our Offenses tab. Our largest customers are ingesting over 1 million events per second and over 50 million flows per minute. Clearly, this is much more than a human or even a large team of humans could ever hope to analyze manually. The main value of QRadar is being able to ingest this massive amount of data and then efficiently detect threats within the context of your business. It does this by understanding the value of assets, which appear in the Assets tab within the company, and those assets' vulnerability to successful attacks. QRadar not only identifies the threat, but it does so in the context of your on-prem, hybrid, and cloud IT estate. So, to start with, and to simulate, and this is the only part of the demo that is simulated, the attacker's arrival onto the first victim's machine, I'll send in some log files to QRadar that include a connection back to a known malware or command and control host. Let's go into the log activity viewer window. So in the bottom here, we're simulating the blue coat log file being received by QRadar, and in the top we can see that it is being successfully received, parsed, and put into QRadar's common event format. We can see that the event has a name, we can see the log source name, we can see the event count, so where there are high event counts, they're essentially entries which are being coalesced or deduplicated, reducing the overall processing requirement for the system. QRadar works by normalizing security event data from any environment, from any vendor, from any technology, and putting it into a common event format that includes things like high-level category, low-level category, event name, source and destination IP addresses, and so on, and a fully extensible schema beyond that. And this means that all of the out-of-the-box rules that come with QRadar for identifying known types of threats are identified generically and with ease, and with minimal effort from the customer who owns the QRadar platform. We can also see, as these events scroll past, where IP addresses are public internet addresses, that the flag of the relevant country is being added to the source IP address column. And we can see the destination IP address, we can see ports, we can see the usernames, in this case taken from the Blue Coat logs, and the magnitude of the events as QRadar sees them, and more about that soon. So let's just stop that ingesting of those log files, and let's go to the Offenses tab and see what's happened. So what we can see is that QRadar has created an offense with a description of internal connection to host categorized as malware. We can see that it has a destination IP address and it has a magnitude. If I hover over the destination IP address, I can see the location of that machine. If I right-click on it, I can launch IBM's X-Force service and find out much more information about that threat. So this is the IP address. Here we can see how X-Force classifies or categorizes this as a threat with a confidence level as a malware host, and we can see how that's changed over time. And we can see here that it's based on actual threat content, or rather malware, being found on domain names associated with that IP address. These are those domain names. And down here, we can see the actual malware, and we can see the hash of that malware. Okay, so let's go back to the attacker's view. Now we're going to see if we can find anything worth attacking in the environment. So to start with, I'm just going to go into the Network Activity tab. I'm going to come back into my attacker's platform and see if I can find anything with the word finance in the host file. If I were on a Windows machine, I would be probing the DNS cache to see which machines the users on that machine had been accessing across the network. So here I can immediately find a host called finance with an IP address ending .15. Let's see if it's real. It is. I can ping it. So now let's use Nmap to scan the host to find out more about it. So Nmap starts running. You can see it's already found a load of open ports. It will carry on doing deeper scans, in particular some fingerprinting, to work out what sort of platform it is without having to log on to do so. It's a very powerful tool to be able to achieve this. If we wanted to and had time to do this, we'd do a very thorough scan and specifically look for vulnerabilities by CVE ID and use those as a means of attacking the machine. In the meantime, let's go to the top of the screen, and we can see here in our network activity view that this network scan is generating this traffic that you can see in front of you. We can see the source IP address is ending in .10 for the most part, destination is ending .15, the destination ports are changing all of the time, and on the left-hand side, you might have just seen that a red dot has appeared against each one of these flow records, and that's because QRadar has identified this as a port scan, and it's associated all of those network flows with a single offense. As we move our eyes right across the screen, we can see that where QRadar associates the ports that it can see being accessed across the network with known applications, it adds that application name to those. So now let's go over to the Offenses tab. Now we can see that as well as the internal connection to host categorized as malware events, we've got a port scan event, and one of the reasons why it's appeared is because it's a port scan of a critical machine, and we can see that that is the finance file server. So let's double click on that and find out more about the rule that caused that to fire. We can see that the rule was associated with 991 flows so far and one event. If we click here, we can see the rules that caused it to fire. We can see that it's the local pawn scan detected rule. And here we can see the rule, the configuration of the rule that causes it to fire. You can think of this as a filter. So essentially, it's looking for local to local or local to remote context, network context. It's looking specifically for flows, and it's looking for records where the source IP address has occurred more than 5 times across more than 50 destination ports within 1 minute. And also that the destination asset has a weight greater than 7. And all of these are very simple to set up or modify. For example, if I wanted to change the asset weighting, I could say, well, actually, that's not an important one. Let's put it down to 1. So this caused the offense to fire, as we can see here. Next, let's go down to the hacker's view again. We can see that Nmap has rather brilliantly discovered that it's a Windows 7 machine with a particular build and the Service Pack 1, and it's done that without logging onto the machine using fingerprinting algorithms. So because it's an up-to-date machine, we're unlikely to be able to find any common vulnerabilities and exposures to exploit. So we'll use a more general purpose attack for Windows machines. So what we're going to do is launch the Metasploit platform, and this is the hacking platform of choice for hackers around the world. It's also part of a penetration testing platform, which if you pay for it, comes with a GUI as well. But we're just going to use the command line version here. So it's very powerful Metasploit. You can see here that it's got 1,819 exploits currently, and those exploits can execute 539 payloads. So to cut a long story short, I'm going to load a resource file that's going to set the appropriate settings for the attack rather than typing them all in individually. Now, the background to this attack is that while I was researching this company, I went out onto the dark web and I managed to find some user IDs and password hashes for this company. So these are the user IDs and password hashes, and you can see that these are the usernames or user IDs, and this is the password hash, and this second part is the NTLM password hash. So the password is encrypted. So what I'm going to do is use an encrypted password to break into the Windows machine. There are many other ways of breaking into this Windows machine as well, but this is the one that we're going to look at today. So let's load the resource file. So rather than typing those commands, I've allowed it to take on all of those settings, and I'm going to show you now what those settings look like. So this attack consists of 2 components. The first is the exploit. So we can see here it's a Windows PowerShell exec exploit, and I've preset the machine to attack the R host as finance using port 445, using the admin share. You can see that I've set the password as the hashed password from the file that I bought and the username. The second part is the payload, and this is the payload that gets executed if the exploit is successful. So this payload is a Meterpreter payload, which is essentially the Metasploit hacking shell, and this is going to execute the reverse HTTPS payload, which means that a Meterpreter is going to be fired back to the attacking host, the one ending in .10, and so it's using HTTPS, so it can't be read. It's my secure channel, and I'm going back to this port, port 8443. Since all of these settings are ready to go, all I need to do to execute the attack is type run. So we can see that it started the handler, it connected to the server as the user. It selected the payload, ran the payload, and it successfully fired that back to my machine. And now the prompt has changed to Meterpreter. I'm onto that machine. So let's bring this back down to size. And let's look at the victim's machine. So this machine is called finance. Am I really on that machine? Let's open up a notepad session. Back over here on the hackers platform, I'm going to issue the command pkill notepad. It's gone. I'm going to start up Internet Explorer. Pkill explore. And it's gone too. So basically, I am on that platform. And as we attack this machine, you'll see events appear here in the log activity viewer. A few have already occurred, which I've missed, but you'll see some more coming in a second. So the next question is, what is this machine? Type sysinfo. We can see that it is indeed Windows 7 build 7601 Service Pack 1. It is exactly what Nmap thought. Who am I? So if I type get UID, I can see that I'm actually no longer a normal user. I've got system privileges. So this user, who's from those password hashes, happens to belong to an admin group. However, if I'd gone in as a normal user, it would have been a simple method to execute the UAC bypass exploit and to have got system privileges from that. So let's go over to the offenses tab and see if we've generated any offenses. Sure enough, we have. This is the PowerShell exploit that I am running now. It's got a very high magnitude. The destination server is the finance file server. So let's find out why the rule fired and what it did about it. Again, let's go down to the rule itself. It's a detected a service configured to use PowerShell rule. It's fired for these reasons. It's a Windows security event log event. It's got various attributes here. And apart from anything else, there's a regular expression match that's found the word PowerShell within that event. And it's because of that that this rule has fired. So as well as creating an offense, the way that rules work in QRadar is that we can change the severity of the source event. Here we've made it maximum. We create the offense itself, the PowerShell exploit in progress that we saw. But this is where QRadar is at its most powerful. What we can also do is automate actions. So we can automate, for example, containment actions. In this case, we're automating a connection to an internal segmentation firewall, and we're sandboxing this host. So where you have high-value assets, and you may have deemed it worthwhile having internal segmentation firewalls in front of those machines, for such an eventuality as this, you can take them off the network until you've dealt with the threat. But equally, we could have run a connection to an IPS, to Carbon Black, or to BigFix to contain the threat. Okay. Now, back to the attacker's platform. I want to search for some high-value files. So let's look for some files ending in XLS6, some Excel spreadsheet files. So this is going to hopefully find some high-value files that will enable us to download them and then optionally delete them. So this is searching the file system of the victim's machine, but also, of course, any and all of the file systems which are mounted across the network onto that machine. So this is far-reaching. We've found 3 results in a directory marked private. So let's go to that directory. Metasploit supports file completion, which is fantastic. So we're in that directory. We're looking at those files. Let's steal them. Now we have the files. Next, let's go into the Windows shell on that machine, and let's delete those files. Are you sure? We're sure. So now the files are gone. So let's go back into the Meterpreter session. A nice, neat command for clearing our tracks or cleaning our tracks is clear EV, which we can fire. and we can see that it's now erased all of the records from the application system and the security log file. I could have run a hash dump from this session. As I'm moving around the network, I can collect these hash dumps and use them for further exploitation myself, or I can sell them on the dark web. And you can see here that these are indeed the same user IDs and password hashes. So now I could maybe install a couple of backdoors, change the user's password, take a picture of them using their webcam if there is one present, and quite easily send it to them with a ransom demand for those files, and a ransom demand for Bitcoin, affording me total anonymity in a country where there are no consequences for me doing this. Maybe I'll reboot the machine for good measure. So let's go back to QRadar. While we were doing that, we can see that the audit log cleared message from the Windows machine came through. And as a result of that, we should see an offense created. So we can see that a critical assets log file clearance has been picked up. That's the Windows machine restarting. Apologies for that. And we can see that offense has happened here. We've picked it up. So if we click on the ID field, we can see each of the offenses as they were created in the order that they were created. We've got the internal connection picked up by X-Force. We've got the port scan. We've got the actual breach into the Windows machine. And we've got the attempt to clear the log file as the attacker tried to clear their tracks. So in a normal customer deployment, all of these offenses would actually just be contained in one single offense in order to reduce the actionable events. But I've allowed them to be created as separate offenses to highlight how QRadar handles or detects threats. So let's go back to the slides and review what happened. So again, we're looking at the anatomy of the attack, and what we saw was that QRadar automatically identified the connection to the CNC host using X-Force here on the left the moment the attack started. We then identified the network scan using network flow data. We then saw the execution of PowerShell and the installation of a new service as we exploited the pass the hash vulnerability. And finally, we caught the attacker cleaning up afterwards. Now, we could have automated our response at any point, and perhaps it was the point at the exploit where we would have chosen to do that. So hopefully this shows how QRadar can detect cyber attacks in real time, and by consuming network flow data rather than just logs, is able to provide the visibility you need to successfully manage cyber attacks. As we can see in the next slide, the traditional SIM is about containing threats that are already happening, and that's what we've just seen in this demo. With QRadar's User Behavior Analytics tool, UBA, you can get a step ahead by predicting threatening behavior based on current anomalous behavior before an attack happens. For example, UBA could have shown that the finance server doesn't usually communicate with the attacker's IP, particularly using non-approved protocols, non-standard ports, and so on. As we can see from the next slide, and this is a screenshot of UBA, it's automatic. It works automatically. It's driven by machine learning modules that automatically indicate anomalous user behavior. No manual effort is required to set this up and tune it. It's driven by the data automatically. And I should just say that it's also contained as standard within the QRadar offering. There are other additional QRadar modules too. So for example, QRadar Network Insights enables us to spot malware file hashes traversing the network, which we're automatically able to contain, as we saw earlier. Also, if an attack has been successful, QRadar Incident Forensics enables us to capture and replay network sessions, including files, emails, and instant messaging as we investigate the causes. So that's the end of the demo. Are there any questions?